truthiness only. So therefore, if I say false and just say if today is Monday without basically saying equal to true, because equal to true is the assumed part. Okay, even for booleans. So of course we understand that this is checking for truth. Okay, here. So because this is false, we are not going to go inside even without saying equal to. But in some cases, we might as well add equal to true, and then then of course it checks for equal to true. That is one part. And then of course you can also say equal to false. Right. So this is the one. So I think this basically you have to select yes here. Essentially, it checks for whether the subject is correct or not. So always make sure you check the subject code accordingly selected and so on. Okay. So that is, I think this one is not. The first question then is this one. So again, there's also some instructions that have been mentioned. We move forward. This one. Okay. Let's start with this one. Okay. So it says, so idea in Python is mostly we're going to see code-based questions. Okay, like this. Maybe a few lines of code, maybe 1 or 2 lines, maybe more than that also sometimes. It will not be too big ideally, but idea is that you could expect a few lines of code also, and then you have to predict the output. And sometimes it may be small segments of code also, like in this particular case, only 2 lines. Right, but nonetheless, the idea remains the same. You have to read the code, understand what it's trying to do, and accordingly predict the output. Okay, this is predominantly the kind of question that we're going to see throughout this paper. Okay, so we are starting this is equal to programming, and that's what we have. Then it says we're going to print what? Print. So this string slicing going on here, hyphen, rather colon, and then you're giving -1. That's okay. And then whatever comes out of this, we are because remember, when you have a string and you do some operations on top of it, particularly slicing, once you slice it. So therefore, whatever string methods are there, like dot replace, and so on and so forth, all the methods are there within the string class. All those are still available, so you can directly call them. Okay. So you had a string. If you want to call replace on this, you can call it. But also, if you take a slice of this or do slicing over this string, the result is also a string, and therefore you can do replacements and things like that. Okay. So in this case, basically, would anyone like to give a shot and try to understand what this is doing? I mean, of course, without looking at the answer itself, but like one by one, please. So I think the person who raised hand is Yashveer. Go ahead, please, Yashveer, first.
Sir, it is just reversing the string and replacing the G with a hashtag on a reverse string.
Okay. And all right, makes sense. And so is going to replace all occurrences of G, or is it just the first one, or is it just the last one?
It's like replacing all occurrences G.
All the occurrences of G, sir.
All the occurrences. Huh? So therefore, ideally, the question, the answer becomes this one. So PRO and so on. So there was a G there. So PRO, G, RAMMING is what we have. There are 2 instances of G, and in this case, I think both of them are getting replaced. So just to reinforce our understanding also, I'll run this here. So essentially, because that part is important. So if I want to have this, I'll see part wise. So think about this way first. I'm not going to do the replacement, see what happens in this case. By the way, this welcome student, I can perhaps comment out for now. Okay, so that's what you get, right? So you are replacing, you're reversing it, as one person pointed out correctly. So this is also a string now, right? This part. So again, I'm allowed to call replace on top of it. So if I'm calling replace, then ideally it'll always also give us a, okay, this case is not giving us a description for that, but nonetheless, let's see. So if I'm replacing G with the hash, with the hash there, then what we get is this, right? So it basically matches the answer as well. Okay, so that is the reasoning behind it. Hopefully fairly clear to everyone, and we'll move forward. Any questions on this? Any further?
No, sir.
Very nice. Okay, so we are going to move forward. All right, here I think some Boolean expressions are involved also, so one has to be careful. Also, there is this concept of unpacking and packing, which we also discussed in some of the earlier sessions. This is with respect to tuples. So in tuples we have packing and unpacking and so on. Anyway, so in this case again we have xyz equal to. So remember what happens is goes by the order, right? In the order in which you are adding assigning on the right hand side, that goes onto the left hand, like that gets assigned to the left hand side in the same order. So basically, blank string goes to x, Python goes to y, 0 the integer, and this is so this case is integer because there is no quotation around it, and the 0 gets assigned to z or z. Okay, that's what it is. If you understand this part, then now it says printing. So you have to understand the idea of truthy and falsy values, about which I think we discussed at length in the previous session only, or maybe the one before that. Right. So idea in truthy and falsy values are some of the values are considered as true when we consider them in a Boolean expression. See, when we treat something like a Boolean, then it could be a value, but if it is treated like a Boolean, then it should be resulting in a true outcome. So if it is a true outcome, then it's a truthy value, as we call it. Okay, I like the spelling also, just to make sure everyone is on the same page. So idea is something like this. You've got truthy values, truth, like this, values, and there's the concept of also on the other side falsy values. Okay, so idea is basically that if you assume that you have a Boolean, right, x All right. Now it could be true. So true is the literal true here, and there is no doubt about it. Basically, it is true. It's assigned to true itself. And similarly, if it is false, it is false. So you understand what it is. But on the other hand, what do you say about let's say empty list? Now this is empty list. Now this is okay. This is a list, right? But what happens if I do if x, right? Now I'm going to print something truthy. Because if it is truthy, then it'll go inside, right? That's what we are saying. If it is truthy, then it'll evaluate to true. If something is truthy, it's a truthy value, then it is going to result in a true when treated like a boolean, like a condition. Under a condition, if something is a falsy value, then we get something like falsy. Hopefully the strings are correct, or maybe it is like this. Yeah, falsy. All right. So that's what we have now. Output here is empty list truthy or falsy?
Falsy.
Falsy. Falsy. Very nice. Now what do you say about 0?
You falsy.
Okay.
Falsy.
Okay. What about this?
This
True.
True. Truthy. Very nice. So again, similarly, we are going to say this one.
Sir. So
Please.
can you mention what are the truthy values and falsy value? Then give a refresher for.
Correct. So I just mentioned that quickly. Idea is that you don't think about truthy values, okay, generally.
Like sir, in a previous session, when I'm attended, the sir is telling me the 0 and one string and
None.
2 or 3 things are falsy value. Other than 3 things, all the values are truthy values.
Exactly. So whatever is falsy, other than that, everything is truthy. Instead of thinking about what is truthy value, you have to think about what is falsy. So essentially, I'll give you that. So for example, I might be missing out on 1 or 2, but that's the idea. So you have none. It's going to be falsy 0, as someone pointed out correctly. False, of course, is falsy itself. So that is understandable. The boolean false, and empty string also is falsy, right? And list, empty list. So empty list, empty string, or string of length 0, that is false itself, 0 or none. These are the ones that I can think of. Now anything other than this will be considered under truthy value automatically. Okay.
The same for set and dictionary also.
Okay, empty set. Okay, let's see. So regarding empty set, I need to check also. So if it is, yeah, yes. So empty set also. So we say something like this, empty set. Because if I say this will be like a dictionary. That also will check. But say okay, I'll just say empty set, because other notation is this, like, because you're not putting anything, so it just comes out like that. Okay, just a second, please. I hope I'm audible and there is no interruption.
It's very clear.
Yes,
Thank you. No, it appears that there's some lag on my end. So in case there's some in the audio, please alert us. Okay. So we have empty set, and just a second, please. Please raise your hand, otherwise taking your question. So that is one thing. What I was saying is, yeah, dictionary is the one pointed out correctly. Yeah, so empty dictionary also. Anyway, so right. So let's see one by one. Okay. So none, falsy, 0, of course, falsy, of course, falsy. There's no question about it. Empty string, falsy. Empty list, falsy again. Empty set is this set which already checked, falsy. And this is the dictionary, right? So if yes, let's assume there's a key here, some name, what do you call it? Test. Okay. So now it becomes truthy, right? Because you have something. No. So if the number of keys in the dictionary, remember the number of keys, not with respect to the values. That also you have to understand, right? So if name is none, it doesn't mean the dictionary becomes falsy. Okay. It is. These are the keys which are making it true or false. Okay. So if there is key length of key more than 0, then essentially consider it true. The same for sets as well as for lists. Okay. The idea clear? Shall we move on to the next question? Before that, there's one person who raised their hand, so please go forward. Question.
Hello.
Yes, please.
Yes, sir, I have a doubt actually in if part. Can you tell me that how do we check if x is true? Then only we will print that truthy value.
Mm-hmm.
I'm asking.
Okay. See, there are two different things at play here. So I'll try to explain one by one. So point number one is if something is a boolean. So let's say what do you put? Okay, so today is Monday equal to true, like that. Okay, then I'm saying if today is, because that's a boolean value, right? I'm just saying true. So of course you understand, right? So idea is that if we are putting something in the if statement, no, then it by default assume that we are saying that if it is true, then we go inside. Okay, it is not as if we have to explicitly say that if today is Monday equal to true. I mean, of course you can say that. This is the same thing. Okay, I'm saying if today is Monday equal to true. Of course it is true, right? So even if you omit this part, it assumes that you are checking for truth, truthiness only. So therefore, if I say false and just say if today is Monday without explicitly saying equal to true, because equal to true is the assumed part. Okay, even for booleans. So of course we understand that this is checking for truth. Okay, here. So because this is false, we are not going to go inside even without saying equal to. But in some cases, we might as well add equal to true, and then then of course it checks for equal to true. That is one part. And then of course you can also say equal to false. So that's also okay. So then if this whole thing becomes true, meaning if today is Monday is false, or you may as well say is false like this, then you go inside. So it'll say truthy now, because of course that's how I put it. No. So if it is false, then you go inside. So this entire thing now becomes true. No. The fact that the variable today is Monday is false. This thing is therefore then again. So this, for example, what I'm trying to say, this becomes like a condition again in itself, and then again it starts checking for equal to true. So the equal to true part is implicit. So you understand what I'm trying to say there? So that is with respect to Boolean values themselves. Okay. Now you can extend it to truthy and falsy values. So whatever is falsy value in the if statement evaluates to false, not evaluates to false, it is considered as a false. So I'll just write that down also, just to be clear. Considered as false or equivalent to, considered equivalent to false when, what how do you put it? When when okay. So I'll not use the word considered together. I mean 2 times. What I mean is this is equivalent to false when considered, even though it is not a boolean. See, this none is not a boolean, right? 0 is not a boolean itself. Like, but what we are saying is the falsy values are such that when you treat them or when you consider like assume it is a boolean, then the value becomes that. Okay. So idea is again one other thing I can explain easily. See, if you have 0, it's okay. But if I say bool of 0, look what it is doing again. It is changing it. It's converting it. So it is converting 0 into bool. See? So now this becomes false. So bool of 0 is false. So that's what falsy values is. Falsy values are values such that the bool of that value is false. Okay. So bool of none also is false. Just a second, please. Let me finish this part. I'll come to your question after that. So none 0, false, empty string, and so on. So similarly, what happens is that when you put something in this in the if statement, automatically it converts into boolean and then checks. Then tries
my
to
question
understand.
regarding this code, sir. Can you run this code in a Python tutorial?
Okay. We can do that, but towards the end, possibly, because I have other questions to go ahead with. Okay, because that might take a long time, and we might miss out on the questions, right? So do this part. We'll come to that maybe towards the end. Is that okay? We can run this one also. It's fine.
Okay, sir.
Thanks. Thank you so much. Okay, so that is the idea. What it does basically converts into boolean by default, whatever you put there, and then checks for it. So what we were earlier saying is we were talking about falsy and truthy value similarly. So we just said that if x is equal to 0, and then we are checking if x. Now what are we checking here? We are of course checking if x is equal to true, right? And 0 is not, so therefore it is falsy. However, if you say 1, no, I think yeah. See, because it is equating it to true. Why? Because the bool part is already there. So it says like this.
So here x is equal to 1. That means
Yeah. So therefore only you're going inside. Inside meaning this part is only printed when it is truthy, no?
truthy.
So that's correct only. Yeah. And similarly anything other than 0 for numbers. Okay. So for some reason handed, this is new. Just a second. What if we, okay, so if you equate it apparently it there's a slight difference. Okay, so it is not equating it to true perhaps because it is not a boolean, right? Therefore, but if you check it without saying equal to true, no, then that is true. So please consider it under this case only when you're directly putting it without equating, because if you equate it, no, it'll try to convert it and maybe it'll result in a wrong value also. Okay, so better to always consider it like this. Whatever value is there, you just put it like a check for it. Okay, so or you could assume that we are saying something like this, bool of x. So now easily understandable, no, what is happening. If 1000 or whatever, if it is negative also still the same. This part is done. Now we will move forward. So anyway, so this was the idea. Now we are assigning it. So x is empty string, no? So x is falsy, y is Python, so truthy value here. Z is 0. So now what it is saying? It is saying x or y. Now can anyone tell me about the precedence order of the x or this thing? So if you have, let us take this one only, no? We'll try to understand it, break it down. So again, with that understanding, here we have x is equal to empty string, y equal to Python, 0 equal to C again. Now remember with or, so there are 3 things, no? And or this way, not and or. Okay, so this is a precedence order, meaning and is evaluated first. Like it's like it's like board mass rule in mathematics. We have that thing, no? What do you do first in the equation? So that like that. So this is like precedence. So you evaluate not first, whatever is like before the condition. If you have some not, then that will negate it. So not of true is false, not of false is true. You understand that, right? You flip that, and this is not of whatever the condition is. Now and is then evaluated. So not and or. This is the precedence. Anyway, so here now anyway brackets are given, so no problem. Here we have brackets given, so it is fine. So remember what happens with or is, if anything becomes false, no, then you go to check the next condition. So y remains, no? Y remains. Is y truthy or falsy? What happens to the entire condition then? False or true is what?
Truthy.
True. That is, yeah. I mean, it's not going to be truthy. I mean, I understand what you're saying, but that'll become like a boolean. So essentially, what I'm saying is true or anything. So basically, anything. You put it like this: anything or true is true. How many ever conditions you have? So you have like or dot or or true. So I mean, you see true here somewhere within or, because you're saying or, no? Thing is true. Okay, the whole thing. Okay, anything. I'll show all the 4 cases. anything and what is it? So and false. Or let's talk about true first. Anything and true is what? So what happens is whatever is true goes away, and then you check the next thing. Okay, so let's say this way. So if A is 1 and B is 0, or let's put this way, true. Yeah, 1 0 is better. So if I say print A and B, what is going to happen? It is going to check for A first. So A is truthy. So therefore this is true. That's fine. Now I'm going to go to check the next one. Or immediately I see A is true. So the whole thing is true. I print true and I don't check the other ones. Because if one thing is true, the entire thing is anyway true. So I need not check the other. There are multiple things. I only check one. Immediately when I hit a true, the entire thing becomes true. Only when everything is false, then in the case of or, it is false. So it is like, you're saying like false or false or false. Then only the whole thing becomes false. But any true is there, no, somewhere, then the entire thing will become true. So the entire output is true. Okay. That is the idea. And with or and is, so when something and something happens, no. So if you have A and B, so in this case, A goes away in the case of and. So what remains is whatever is remaining, because A is already true, so you don't care about that. You simplify it. So you eliminate that. Right. So B remains. Now you check for B. Is B true or false? B is false. So what happens? True and false, what happens? The entire thing goes to false, right? So anything and true is whatever remains. So is the other thing. Everything all except true ones. Because true ones go away, no? We just ignore them. So whatever, because whatever is already true, I don't check that. I check the next one and the next one and the next one. But if I hit a false, then that thing goes to false. Now there are, yes. So now I'm talking about the false case. So anything or dot 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 or somewhere you get a false, right? Then what happens is all except false ones. So whatever happened in the true case for and, no, whatever remains. The rest of them are going away, right? Only the rest of the parts are remaining. Similarly, in the case of or, that is what is happening. In the case of false, so or with false, the false goes away. So you simplify it to, so for example, if A is like 1, B is 2, C is 0, and then I'm saying C or A or B. So I first of all I check C. So I see C is already false, right? So now I remove this. So A or B remain. Then I check A or B. So A is true, no? I say A is true, so entire thing is true. So I just say true, like that. So whatever remains in the case of or false is everything is everything every term, I should say, every term except false ones. In the case of or false, because false ones will go away. You check for the next one for the truth essentially. Similarly with and, what happens is if something is and, multiple ands are there, and immediately somewhere you see a false, then the entire thing becomes false. So and anything and false is false. So anything or true is true, anything and false is false. In between, anything and true is all the true ones, rather all the remaining ones except the true ones which are already there. So true ones are eliminated, like removed, simplified, they are ignored. And similarly with the other case, with or with false, every term remains except the false ones. Okay. So here every term. Is that okay? Makes sense? Understandable, hopefully, what I'm trying to say here.
Yes, sir.
Okay, very nice. So with this understanding, we'll see. So now here we are saying x is equal to blank string or y. So what is x? X is falsy, right? X is falsy. What is going to do next? Y remains, no? Because or false or something. Go ahead.
So I understand the order of how to solve this type of question. First we solve not and r and fin r. But sir, when the question is coming like this, like 2 or 3 brackets, the any rule exists like a bedmask rule. First you solve and then any rule
No. So
exists?
you go left to left to right. Left to right. Okay. Yeah. Always left to right. So first I'll see this one. Because there are 2 brackets. I start from the left. Always. This is always the case. Okay. So you come here first. Now I have x or y. So x is what? X is falsy. Why? Because blank is string. No, this one. So blank string goes to false. So what happens? Y remains. I'm going to check y. Y is y true or false?
True.
True. So this becomes true. Now true and, what happens with true and anything? So assume that this is anything, something. So true and something, what happens? True and
So
something
we will
equal to,
check for next.
yeah,
Last one.
something basically. True and something is equal to something. True goes away. That's
Yes,
what
sir.
I mean here. Every time except the true ones, because true ones you remove because that's already true. So you check the next. So true and something is something. So that's what we are saying here. If you undo that. Now we have
So
true
here,
and this
here
thing.
something is
This.
true also.
Something is true because why? Z is false.
Z is false and len y is true. So it is
Yes, sir.
true.
Length of y
True
is
will be taken for this bracket.
true. Yeah. Length of y is true. Why? Can anyone point out? What is the length of y?
Because the length of y is
6.
6, right?
So Z or 6. Now what happens? 6 is true. So this is true. Immediately I see a true. Anyway, this was false. I check from left to right anyway, always. So this goes to false. False or anything. False goes away.
False.
Other thing remains. So this is true
True.
anyway. So the whole output is true. Now undoing to the beginning. Let's say if we get the right output, so it should be true. Idea was that you wanted to drill down and understand what is happening. Okay. So I forgot one part. So what happens with this kind of approach? No, because you're not converting it to Boolean. The last thing to return, whatever returns the last thing, is given back. So if you assign it, so for example, if I have result equal to z or length of y. So if something is false, no, then that is of course false. So we don't consider that. But in the other thing, whatever is true, because of whatever object it is becoming true, like in this case length of y, that you return. Instead of true, you return that, like the final thing because of which it became true. No, so instead of actually saying true, you return that. So because of length of y, it is becoming true. No, it is truthy because of that. So that last value is being returned. Okay, that you have to be careful about it. So it's not going to be true actually. Okay, it returns the last thing. So here the last thing because of which it is becoming true is that. Yes, Yashvir, please go ahead.
If the both conditions are true, then what value will
Last
it
one.
return?
That is also a good question. So see, if both conditions are true, so I say 10 or length of y. Okay. Now 10 is truthy and this is or. Okay. So 10 will remain. So I print the result now. Here 10 will remain because immediately you see that. Immediately you see and this became truthy. So because of this it was true anyway, the whole thing. So I did not go and check the other one. So I returned this one. In the case of and, however, again same thing happens. I check this one, but I go to the next one also. I check the next one also, and I return the last one. So in this case, I think length of y. Yeah. So in this case, length of y. So in the case of whatever is the last thing, because remember always in the case of or and both of them, you go one by one and check each and everything. So the last thing at which you stop, that you return. Okay. So for example, in the case of or, I only check this, and I don't go forward. I need not check the other thing because it is or, right? So one thing is true, the entire thing is true. I don't check the other one, so I only get 10. But if it is and, I must check all the things, right? So therefore, I go to the next one also, check this one, and the false case also I'll mention. So 0 with or. Now this is already false, we understand. So I don't pick up this one. I go to the next one because to see if it is true, and this is truthy. So we'll pick up this one. So this one is picked up, length of y. So if I put 0 or 10, then 10. Okay, that's what. Now similarly, if it is 0, then what happens is basically you return the last one, I think. No. Okay, so if it is falsy with and, then you return the left part. Because you don't go to check the next one, right? That's what the idea is. Think about how the computer is doing it. It's going from left to right and checking that if I can come to the conclusion directly. Like I see it is and, I see it is 0. So I understand immediately it is false. I don't go and check the next one. If I'm not checking the next one, then whatever is the last I checked, whatever is the last value that I checked, I'm going to return that. Okay. In the case of
Basically, sir, basically go for left to right, and first he got the falsy value, then it directly gives an output. The falsy value.
Yeah, in the case of and, if it is falsy, then falsy value. Okay, so maybe what I can do is I can also write that down. See, if you have something like falsy and something, so the output is falsy.
Falsy.
Really? Yeah. And you could have falsy or something. You see? So
Something.
in this case, something. And you could have truthy or and something. So you return actually something basically because you go to the next one also. But it depends. See, here it depends. If this something is false, so this could also happen. Order matters here. So assume that this one is truthy, so I have 10, and this something is false. Something is, let's say, something is 0 or none, 0. Or is it going to be false? Let's see. Ideally, I think it should be
0.
okay. No, it will be 0. Okay, so you always go to the next one. Yeah. So truthy and something is going to be something. Whatever the last value that you checked, be it false or true, the last thing that you check, you return that. Okay. Now truthy and something is going to be this, and the last thing is truthy and or something again. So truthy or something. The thing is that with or is that immediately you see truthy, then you don't return something. You go to truthy directly. So this is what. So here I can show you also true or. So instead of this 0, I could do or also. And even if it is 23, let's say both are truthy, right? But if, even in that case, I'm going to return the first one only because that's how I evaluate from left to right. Okay, so I'm going to have 10. You see, with the case of and, you always go this way. So this is helpful. Remember this one. Okay. So value is not required. I mean, you understand what it is. Okay, so yeah, so with that, so again, so x or y, x is falsy, so we return y, but y is Python, so we are saying what? We are saying Python and, so essentially if you simplify this, substitute this is saying Python and, because y is Python and this thing, so this and is already truthy, so this goes away, right? Now I'm seeing the next condition. You should not remove it, okay, but I'm just highlighting it to show you. It's not as if you're removing it. When you're evaluating, you do it by hand and you check it, okay, like by doing it on the notebook or the page, essentially whatever is the page that is given to you. Okay? On that, you can write it down and check. Okay, but I'm just showing you by removing it. Ideally, it should not be removed. Okay, now I come here. So here I have z. Z is what? Z is falsy. Yeah, because of 0. So I don't take this one. I take this one. Okay, because again, this is what falsy or something. So falsy or something, I'm going to return something. So that something is 6 in this case, and therefore I'm returning 6 here, and therefore the answer 6. Is that okay? Makes sense? Understandable to
Yes,
everyone?
Excuse me, sir.
Go
sir,
ahead.
direct given a value, what you take? It's can't give the truthy value and falsy value. Direct give the value who take. Can you repeat once more, sir?
Yeah. Basically, the value which resulted in the truthiness and falsiness of that. Like, what is the last thing you check? No, that you return. Like, this is the last thing that I checked.
Okay, okay, okay.
I was checking one by one. I was breaking it down and then looking at each and every.
Z is a falsy value and length half y is a truthy value. Then it's
Something.
printed output in a truthy value like 6.
Correct. No, even if it is a falsy value, that's also a thing. Okay, therefore I said something. So assume both are falsy. Which one is going to return? So Z is falsy, and let's say none is also falsy, right? Or Z is 0. So Z is what? And 0 is falsy. So it's empty string. It is going to give or 0. It is going to give
0.
in this case 0. Yeah, that's what. No. First one is okay. Y is not falsy. X. Sorry.
Yeah, sir.
Sorry
It's
about that.
take
X.
a truthy
Sorry.
value first.
Yeah. So it takes both are falsy here. But even in that case, I'm giving the last one. Okay. So that's what the idea is.
Sir, can you scroll down, sir?
Yeah.
I take a screenshot for falsy values what you mentioned in the code. Yeah.
Oh, here. Okay.
Yeah. Can you
Yeah.
take,
I mean, this notebook I'll share with everyone anyway.
Okay, sir.
Yeah, but anyway, you can take it if you want. Fine. So we move forward with that. So 6.
Sir, I have a doubt.
Please.
So, sir, here, like, even if brackets are present, we don't need to see those brackets in logical operations.
I mean, you have been given a precedence anyway. So even if you don't consider, yeah, I understand. Sometimes it might create ambiguity. So we avoided that. I mean, basically because you might not know what the order is, right? So better not to get confused and have that bracket. But even if it is not there, yeah, because we have been given a precedence, there is an order in Python. There is an order in which things are going to happen. And therefore we take it like that.
So, like, presence or absence won't make a difference. We always should consider
no.
from left to right.
In
No,
some
this
cases
code
it
it
does.
would have changed.
In some cases
Remove
it
the
does. I
bracket, it will
think, yeah.
change.
In some cases it does. So let's see why. It does. This one is a good one. So I'll show you how. So what it is returning 6 right now, right? So if I remove it, let's say from first of all, this part still 6. This part also still 6. And if I put it this part, but not in the other part. See, remember, it is not that for every is a precedence of
Sir,
what did do
sir, your voice is
first.
breaking. Sir.
Okay, first or an and, right? But still you might have a tie. Okay,
Sir,
so
your
to
voice
break the
was-
tie,
Sir,
your voice is breaking,
could
sir.
not listen.
Okay, I'll repeat that part. Idea is that audible now?
Sir,
okay.
can you remove
Yes,
the bracket?
yes,
Sir,
Yeah, I'm
can you remove?
So here in this
Sir,
case,
in-
even with bracket
it's
or
printing
without
6,
bracket,
no, sir?
answer is same.
In this
Excuse me.
question, it is printing
Go
6.
one by. Just a second, Rajmani, could you please raise your hand and come in the next after the previous person is finished? Actually, we'll go one by one. Otherwise, difficult to
Okay, no worries, sir.
take up the notes. Yeah, go ahead. The previous person who. Yeah, Varsha, go ahead, please. I think you had a question with respect to brackets, right? I think you're not audible. Okay. So anyway, in this case, what I was saying is, in this case, I mean, it does not matter, okay? But not in all cases, it would be that brackets do not matter. In some cases, they do matter. When you come across that condition, we'll try to explain that part also, because we don't have that example. I mean,